Hi, this is Professor Snell, and this is a how-to step-by-step video for exercise 1 of building construction 2. So the first thing we need to do is download Climate Studio for Rhino if you haven't already done it. There's a link in the assignment, and there's also it's also posted on Canvas. It's a simple process. There's an install link and a license key. I should just mention that even if you've had Climate Studio before, you're going to have to reinstall it because we have a new license, and that will be true every year. We're getting a new renewable license from Climate Studio. Okay, so let's assume that you've installed it, and now let's set it up in Rhino. You'll see that there's a Climate Studio tab when you open up Rhino after installing it. And so this is one place you can access the tools that we'll learn a little bit about this semester, and we're going to be using Climate Studio in other semesters, so that's why I'm just getting you started on it. Uh, let's do this. Select the Results tab, and this panel will show up. What I like to do is dock the panel to on the right-hand side with my layers to the right of it. And the reason I do that is because I always want to see my layers, but I don't need to adjust their size very often. Whereas you'll see in Climate Studio, we really will be adjusting the size of this window. Then I'm going to come here and select this settings wheel and also select CS Workflows. These are the two basic tabs you're going to need for Climate Studio. So now we're basically set up to get started. So let's look back at the assignment. The next thing we want to do is, well, maybe not the next thing, but each student, so you're going to be in groups, but this is an individual assignment essentially. You're each going to make your own model. Uh, you each need to choose a climate file. And so one of you is going to pick New York, and the others are going to pick climates that are considerably different than that so we can compare them. The way you do that is if I'm in my Workflows tab here, and I go to this little Earth, this folder here allows me to access a bunch of climate files. So for example, if I type in New York, um, there's a number of, there's Central Park, LaGuardia, Kennedy, downtown Manhattan. I could put in Las Vegas. Um, and there's 3 different Las Vegas files. So there's a lot here. And all you do is select one and say OK, and it then automatically brings it into the CS workflow. You'll see that we have a summary of the climate down here that's similar to the one that was in the lecture today. So we have lots of basic information about the climate before doing anything. By the way, this is also where you can turn the compass on and off. I would always have my compass on. Another place that you can find climate data, if you want to find, someplace in Sweden because you've been there, and it's not in the library, you can come to this link, which is just a map of climate files. And by the way, you'll see it says EPW map. We are using the EPW file format. That stands for Energy Plus Weather, and Energy Plus is a simulation program actually developed by the US government. Anyway, it's typically the background for any of the simulations that you'll do, and any climate data is a simulation. So if I just were to select any place I wanted to get climate data for, I can just download it or copy it. This is actually a zip folder. You have to unzip it and then use the EPW file in Climate Studio, and so that means you'd have to put it somewhere in your computer where you can browse to and find it here. I'm assuming most of you won't do that, so I won't go into more details, but anybody wants to ask me any questions about this, no matter what section you're in, please contact me. I'm happy to talk to you about it. Okay, so now we have a climate file, and we can change it very easily. So if I want to come back and say, no, I actually want to do New York, let me do Central Park. I've now updated that, and all this data is now updated. By the way, we can change the units here. SI is metric, and IP, if I click on that, is inch pound, which is what we use in the United States. So we're using inch pound in this class. I will say that in Climate Studio, these are Europeans making this. It's a group of people at MIT actually, but this heating degree day and cooling degree day number is wrong. So if you want to use heating and cooling degree days, you should just talk to me about it, and we'll do a conversion. It's pretty simple. So we've downloaded Climate Studio. We've got a climate file. Oh, one other thing that we should mention is that we want these to be in the units to be in feet. So typically the default is meters. So just make sure that you're not in inches or meters. You're in feet here. You can always change it later and scale the model, and we'll do it automatically. But it's just smart to get it right from the beginning. All right, so we've got everything set up. The next thing we need to do is create a massing model in Rhino. So to do that, if you haven't used this before, there's a great tool called CAD Mapper. I'm going to sign in. It's free as long as your model, your map is less than a kilometer square is free. You use it like Google Maps. I'm just going to type in. I'm going to use Bryant Park for my example. Um, you're going to be using whatever whatever site your professor assigns. Uh, okay, so I am now at Bryant Park. Here it is in the middle. I am at 712 kilometers, so I would pay $6. No big deal. It's pretty inexpensive, but I could make this much smaller and get easily get below the pricing threshold. All I do now is say create file. Here's what my file is going to be, and it's now generating it. And here is an axon to show you basically what it's going to be. If I like it, great. I can also edit the map here and go back and change it. I'm going to download that. You can see they're also pretty small. 407 kilobytes is very small. Um, and then that downloads to my downloads folder. It is a zip folder. It's zipped. So if I have to unzip it, extract it, and now here's my model. I'm going to open it. I think I opened it twice. Let's see what happened. Yeah, so I just clicked on it twice, which I don't know if you've had that happen to you before. It happens to me all the time. I click on things too much, and then I open two versions, so I had to close one. Um, and so here's our Bryant Park site model. Pretty simple. It comes in. Let's go to layers. Um, we have a bunch of layers set. I mean, the model is divided into layers already. For example, buildings is a big one. I love that if you do New York City, there's all the subways. So, here the subways are going to disappear when I turn those off. So you can pick what you want to display. Definitely, though, do the following. Create a default layer first. Always have a default layer in Rhino so that you can have a layer with nothing on it. It's what I use it for, so that I can come to here and then be able to turn off everything. The next thing I'm going to do is organize my layers. But let's go back to the assignment so we can see what we're doing here. Okay, so we've downloaded the CAD Mapper site, and now I'm going to organize this into layers. And all that means is that I want to be able to turn off my site and easily be able to manipulate the model. So I'm going to create a main folder called site, and I'm going to put all of these um, all of these other layers into it. I'm sorry, including topography and contours. Now you can see this is what happened is that because, well, anyway, I won't explain that. So now I have everything in the model in one layer, and I can turn it on and off. I'm also going to create a layer called massing, and in that, I'm going to create two layers. One I'll call massing 1, and the other I'll call trees. So the next thing I need to do is bring in some kind of massing that I can use in my site analysis. So for the sake of time, I've already done this in another model. I have several massings that I'm going to use or that I brought in. I turn on my massing layers. Uh, the first thing I did was just, and I'm suggesting you could just do this in the assignment. If we look at our program for our work this semester, there's a large space that's 50-foot wide by 120-foot long by 30-foot tall. There's some other stuff going on, but we could just start with that to get this done, to just have something to work with quickly. So I made I just extruded a box, 125, 50, 30. Um, and brought that in, put it on a layer so that I can control it, and that's this. I also, you can go a step further, and if you look at again, this is our program. Essentially, we've got two cores. Let me actually ungroup it so I can. We've got two cores. We've got that long span space. We've got the office. This is actually parking. So I don't think we'd have parking in Bryant Park, but of course we're not going to be building in Bryant Park. This is just an example. So I actually took this program and combined it into a sensible massing. Um, so here's my long span space. Here's one of the cores there, another one here. Um, the office space. I put the parking in the back. So the point being, you don't need to do that right now because you have plenty to do on this assignment, and we want to make this manageable and quick for this week. But as you move forward through the semester, I would quickly come up with some kind of massing that you're going to, as your design, that you're going to use for all the different assignments, and bring it into the model. You always want to be updating your model as you design because you need this information, and it's really easy to obtain. So you might as well always use it to inform what you're doing. All right, next, where are we? Um, we just placed the preliminary siding, and so the next thing is to adjust the model. CAD Mapper brings in a lot. They don't do everything. One very possible element you'll need to add are trees. So like in Bryant Park, if we come here, there's a lot of trees, and trees can be tall. They create shade. They're also often important, and you don't want to forget about them. So because you don't want to assume that you're going to cut all the trees down. So one way to quickly there's the whole idea of the whole question of how you represent trees is a big debate often in architecture classes. Um, but there's two ways that I would do it in Climate Studio. You can actually, I'll go to the top view, just scoot over here somewhere. Um, you can just make a series of circles to approximate some kind of canopy. Just sort of overlapping. Oops. And then turn them into planar surfaces, and then lift them up some distance that you think is represents the canopy. So let's say I would say 35 feet. Um, Oops, that's just the curves. Right, so now I've got something that will create shade that's 35 feet above my plane. Another way I could do it is by just using the curve tool and create that into a planar surface. By the way, if you sometimes you'll be doing that, and you will find that you didn't have a closed curve. So if you don't have a closed curve, if you select, let me just do that. If I see if I can do something quickly that doesn't quite close, but that will let me automatically close. So if I say, um, let's just see this, you see here that this is an open curve. If I say close curve, it did close it, and so now I have um, a closed curve, and I can make a planar surface with it. Another thing that sometimes happens is that when you draw it, you get out of plane. In other words, it's wobbling, let's say. And so there's another command that is project to C plane, and that will flatten it out and send it down to whatever your C plane is. And then you can make uh, you don't want to, you want to delete the input, yes, and now I'll make this a planar surface, and it works. Okay, so I already did that here. And how did I do it? I went to, like we already said, oops, okay. I went to Google Maps, got a general idea. I've been to Bryant Park. I know something about what the trees are like. You always want to go to the site if you can. Um, and I just created some, really simple. This is not accurate. This is a little bit weird because, trees obviously have a lot of depth to them. This is just a single surface. I could make multiple layers if I wanted to. But for a first quick model, that's fine. So I have it on a tree layer. All right, so now we're ready to actually start doing some analysis. Um, what you, what the first thing to say is that if you're, especially, right now, it's fine to just do this in one place. But as you start developing, and again, we're not really doing a complete design in this class. We're focusing on construction, but we will have a site. And as you develop the project, you may want to bring in more, more accurate modeling into this context. And so you may want to start thinking about where's a good, trying different sites. I can move this building around and try different analyses in different places. So you're free to do that, but for today, I would say we just keep it as one. Um, and so we are now going to do three different simulations: a solar shading study, a wind study, and a radiation map. So the solar site study, all we need to do is, first of all, let's just turn the sun on. And how do we do that? Okay, I haven't described that at all yet. In my workflows tab here in Climate Studio, I have all the different workflows that are available. These are the same things that are available over here, so I can click on these individually. Um, but we're going to start with site analysis, which is where we were. And there's these two tabs here. One always takes you back to where you can change your climate file, turn on and off your compass. You can actually do an offset. We can move the site if we want to. You see that the compass is rotating at the bottom here. Um, and then we have the actual site analysis, which has sun, wind, and some other charts that we won't discuss right now. So if I turn on my shadows, the sun shows up. And now this is different than the uh, onboard Rhino sun. I would not use that one. I would use the Climate Studio sun. I can also turn on my solar path, and I can position that. So if I don't like where it is, I'm gonna set the position over here, or I think I'll move it back to here, and I can change its size, its radius. So I could make it much larger. Oh, I'm sorry, it was smaller. That's weird. I thought that was larger. Oh, I think that, well, yeah, wait, what's going on here? Let's see. Let me check the units. Oops, not right command. No, I'm in feet. Okay. Um, anyway, so I can make it 1,000, or I can make it 100, whatever, right? Um, I think, let's just keep it at 1,000 for right now. And we can turn that on and off. I sometimes, it's really good to use this as a way of understanding how the sun moves. So you have um, 4 baseline settings here. We have winter solstice, which is about December 21st. We have summer solstice, which is about June 21st. And you see that the sun, let's say we're both at noon here. We see the full extent of the altitude change for the year between, it's the highest in the summer, lowest in the winter. And we can scroll through the year and look at things in more detail. We can pick exact hours of the day and see where the sun's going to be. And we can do this with or without uh, the solar window path. So this is a very powerful, very quick tool to use. What I want you to do for this assignment is save a view and just make a bunch of screenshots. So, if we go to just the top view, we'll be facing, so that the bottom is going to be south. And we could use that. So we could just start here and zoom in if we want to. Um, and I would then save over here in our panel. I would turn on named views. You do that by clicking here, find named views, turn it on, because now we can save views. So if I've already got some saved ones in here, but let me just make a new one. I'll say, um, you know, top south. And now I can, go to a different view or just move around where I want to my model, and I can come back to that view. So I'll always be able to um, quickly come back to the view to see it, but also to make accurate screenshots. And so we see here, if we just go through, then what the assignment is to go through um, all the winter solstice, the summer solstice, and one of the equinoxes, so halfway between the solar path, and start with 9 a.m., go to noon and 3 p.m., then switch to an autumnal or a vernal equinox. Those are 3 months after the either winter or summer solstices. If you don't understand any of those terms, ask us and we'll refresh your memory. So 9, 12, and 3 at one of the equinoxes, and then the same for the summer, 9, 12, and 3, and take screenshots. And once you lay those out on a page, it's a very good way of comparing or seeing how the sun is going to interact with a site or a building um, throughout the entire year. You might want to pick a slightly different, like something with an angle to it, like this side or something a little further back. It's possible. Don't get way back, so you're not, because the point is we want to see the shadows on whatever it is we're designing. But I might want to look at it here, for example, because then I can actually see some of the faces of this massing, and that's going to change quite a bit between, uh, let's do noon. There's a huge difference between the summer at noon and the winter at noon, and we can see how the difference is on these faces, just, in some general way. So that is um, the solar study. And you can see down here in the deliverables, just 9 screenshots of those 9, 12, and 3 on those 3 different days of the year. And each member should do their own so that we can have something to compare. The only thing you're really talking about together right now is just what your climates are going to be. Make sure they're different. All right, so the next thing we're going to do is a wind study, or just we're gonna look at the wind on the site. Um, in this case, I'm choosing a straight-on view. I'm going to turn off the trees. Go to ghosted. And now we're going to set up our wind rows. So I'm going to come to the wind tab here and make sure the the wind rose is showing, and I'm going to set its position. So set position, basically in the middle of my site. We don't see it, and that's going to be because there was something, probably the topography was blocking it. It's fine to just go to a wireframe for this if you want, or play around. If I turn off the topography, it might be that if I can go to ghosted and see it. I can also turn my building off if I want to. Your choice. But the point here is that and this is referring back to what we talked about in the lecture. Right now, what we have is the entire year wind on the site. That really doesn't tell us anything because it's just an average of the wind for the year. But by the way, let's look at this wind rose and just unpack it in a very simple way. Obviously, we have directions of on the compass. So this is, we're coming here from the northwest. The colors are speed. So the darker colors is faster, the lighter colors are slower, and the length is the amount of time. So I think that's a pretty clear, even just intuitively obvious graphic choice they made. But here's the main point. We need to pick heating and cooling seasons to display the wind, or it really makes no sense because we may be wanting to block the wind in the winter and let it in the summer, or there's different interactions with wind based on our desired interior or our relationship to the outside temperature and other climatic variables. So, how do we adjust this? So we have these toggles here. By the way, these overlap one another, or they can. So if I want to do, I'm gonna do winter first. So I'm gonna say winter's gonna start on November 1st or so. I don't have to be exact. And I'm gonna go to the end of April. You see now this is the new windrows down here. By the way, I can print these or do whatever I want to with them if I click on this little icon down here, and I can see more about the details of what the actual numbers are. I have other stats, but in order to see this in the model, I have to turn it off and turn it back on. Okay, so that's our winter wind. Let me actually just take a screenshot of that. And by the way, when you're taking screenshots, just pick some, maybe coming from this point to this point, so that you always have the same size screenshot um, for comparison. But now let's switch this to summer. So I'm going to bring this to over here. We're going to wrap them over the other way. I'll start the summer in May, and I'll go to the end of September. And I'm going to change my windrows, and we can see that that's very different, right? So we need, so we could actually use the wind in different ways here um, for heating or cooling or at different seasons. The other big point to make here, though, and I made this in the lecture, is that, if you look at this site, we're in Bryant Park, there's a lot going on here with wind. All these buildings are going to block it. It's going to swirl around. Um, so it's not really a very reliable resource, and you really, if you want to design with the wind in a anything other than a stacked ventilation type way, we'll talk about that next year. You need to know a lot more about it. You'd have to have probably a weather station on site. It's totally something that can be done, but just take these with a grain of salt. And I also showed in the lecture that if I this is the LaGuardia climate file. If I switch this to Central Park, it'd be very different, which it should be because that's a different site. All right, so now we've done the wind. And all you need here is the two screenshots of the two seasons. Um, Now, finally, let's look at radiation maps. Now, the reason that we want to do a radiation map, this is something important, uh, and it's changing in architecture, is because we want some kind of quantities. It's great to see the sun. It's great to get a general idea of the wind. But we can go much further with that than that, and it's also very easy to do that, to go further. So let's just look at an example of it. So I'm going to switch to my radiation map workflow. Let's just set it up, and then I'll run one, and then I'll describe what it is. So I'm going to go to, let's see, I'll just go to shaded. All we need to do to set up a radiation map simulation is two things. We have to decide, well, actually, I do need to tell you what it is then before I can move forward. And I'm gonna go back to my site analysis, and I'm gonna turn off my windrows just because I don't want that showing up without thinking about it, without needing it. Okay, so a radiation map, um, we we pick a surface or series of surfaces that we want to measure the amount of sun energy hitting that surface. Um, and let me switch back over to the radiation map. That's going to be our surface that we're testing. It's our it's the place we want to know how much sun is hitting. Um, Then we need to choose what other things in the model we want to interact with the sun. In other words, essentially block it or reflect it. And so that's we're going to have to apply materials to those things. So, for example, if I turn off the buildings, then there won't be any buildings in the model, and we'll get a very different radiation map than with the buildings. But even if I turn them on, if I don't apply a material to that building or that layer, then it will not be part of the radiation map. So that's really important, and you should start using your common sense. If you get a situation where you're getting way more sunlight than you think you should, then just ask yourself, oh wait, do I have everything set up in the model that I need to have set up? Um, what we do here is, so I'm going to put, let's see, I'm going to do the topography, and okay, I'm going to turn off the rest of these so they're not even showing up here. Um, so I guess, maybe it's good to have them there because so we can remember what the site looks like. But the only two layers I'm going to apply materials to are going to be the buildings and the topography. The way we do it is we just click on the layer and this library opens up. We have glazing and other, which is everything else. So just use other. For the buildings, I would just put some kind of concrete. So there's tons of kinds. It doesn't really matter for this situation. I'll put exterior wall. So now that's applied to all these buildings. For topography, I'm going to put in asphalt. Doesn't really matter which one. And you can change these and play with them. It's interesting. But for this simple exercise, that's all we're going to do. Then I need some kind of surface to test. In this case, I mean, so I could come in here and let's see, this is my massing. Actually, I've already looks like I already have this on. Let me turn these off. Yeah, I'd run some stuff in this model before. Um, so I could select like a roof, for example. You can't see that's I'm not sure what's not selecting. Maybe it's not on there anymore. I could turn this roof um, into a surface that I add here and let it be the testing surface. What I'm going to do in this case um, is just the ground. So I'm actually going to turn my building off. I'm going to make this entire uh, park a collection surface. And so what does that mean? Let me turn this one off and I'll make it again. So I create so this ground, let me select it, is just a single planar surface. And then if I'm going to add that as a surface, so let's review. I've got my buildings and my topography, which are going to basically block the sun, and now I'm going to add the surface that I want to measure. All I have to do is click on this little plus sign. This dialog opens up. I'll just name this one um, park ground or something like that. You don't need to change any of these other things. This is just how closely spaced the sensors are. Each of these black dots is a sensor. Um, and then I could say OK and create it. And then what happens is it creates a surface that has these sensors on it. All right, so I'm now ready to run the radiation map simulation. So let's just do it, and then we'll talk about what's going on. Actually, oh, and then I think I do want to add my trees. I forgot about that. So let me add that layer, come back to here, trees. It doesn't really matter because it's just blocking the sun, but I'll put in, let's see if there's something with trees in here. Yeah, let's see, tree foliage. Okay, but now for starters, I'm actually going to turn those off. I'm going to turn off the trees and the building and just have the topography. And I'm going to run this simulation. And so our results, I'm going to switch this to, and actually, by the way, nothing's stopping. You can see how this is still, there's 100 passes for all these simulations. You don't need to let it go all the way. If it doesn't seem like anything's changing, we're fine. I'm going to come back here and switch to IP because that's what I want my units to be, and come back to my results. So what we see here then is we have on all surfaces 455 kilobTUs per square foot per year. You don't really need to understand what a kilobTU is right now, But the point is, this is an amount of solar energy that's hitting the site. We're doing total exposure because I don't want to explain the difference between the direct and indirect right now. We don't need to know that. And all hours. This is all year. We could come in and look at the warm or the cold hours, so the heating or cooling season. That'd be an interesting thing to do. But right now, we're just getting a basic baseline number. But here's the point I want to make. So we're at 455 kilobTUs per year. It's pretty consistent all across this. All these sensors have about the same numbers on them. You see as I mouse over, um, the sensor number changes over here in this window, and the numbers change slightly. We have averages per month. So there's a lot of information here, but we're just doing something very general. So now if I come back and I add my trees and my buildings and my topography, well, topography is already there, and I run this same uh, radiation map again, come back to my workflows, hit run. It's going to take longer because there's more stuff that needs, there's more math because there's all these buildings that need to be considered. So I'm actually going to pause. Okay, so we can see this is taking a lot longer to run, but it's also not changing very much, so I can really just go ahead and stop it, and I can tell you why this is a big innovation that they did with this version of Climate Studio, which just really helps. We don't need to run full simulations. But if I, so let me stop it. And so we're saying with the trees and the buildings and everything, we're at 181 kilobTUs per square foot per year, and without them, we're at 455. So it's a huge difference, and we can actually get a number. We can make a percentage difference if we had, So then I could also take the trees out. So I say, well, let's say I want to cut all my trees down. How much more sun is that going to give me? And I can run that again. Uh, so what we have here then is the next step from the solar study. We have, let this just get started here so we can see a difference. I'm going to let it run for a couple of passes. That's close enough, I think, just to get an idea. So what we were saying, and I should have labeled these. I should have said no context, um, buildings, trees, and then this is just buildings. So we went from 455 um, to, with just the buildings, 297, and then with the trees, 181. And that's an average. Down here underneath the trees, it's much lower amount of sun hitting it. Okay, so that's essentially all you need to do. And you don't really even need to understand, oops, got a typo. We can talk in class once you get this data together. We can talk about what it means and see how we can use it this semester. And so then you have pretty simple layouts, not looking for anything fancy here, just want to have things that we can compare. We'll look at them in class. So it's a single multi-page PDF of all these screenshots that you're going to take. Please always, when you're, with me at least, when you're working with any models, um, include your Rhino file and any simulations in the submission. So let me show you how that works. Um, you'll notice right now that in this model that I'd done some stuff in here before. I've got, uh, I click on these name simulations and I get the results displayed. The way that works is that, let me go to it. When I create a model in Climate Studio, so for example, this is this model, I named it, and then as soon as I run a simulation, then Climate Studio creates a folder with the same name, so this folder here, and puts the simulation in that folder. And so when you turn in a file to me or a model to me, I need both the model and the simulations folder. And so the easiest way of doing that is just to zip them together um, and then just upload this because that's a single file. You can email that, you can put it on Canvas, whereas folders you can't. A couple of things. A lot of technical architecture is about being disciplined and organized. One thing you always want to do when you open up a model in Rhino that you're going to simulate anything in, is save it with a name. And when you do that, then it will create this folder. If you don't do that and you run simulations, it puts them somewhere else that you have to go find, and just it's easier to avoid that. If you do, though, move this file or change its name or something, the next time you open, this is what you're going to see. You'll see that you can't access the simulations, and there'll be red text here. All you have to do, and it tells you where it's looking for it. All you have to do is go relink that. So I'm going to go to the NYC no context. I know where it is. It's gonna it opens up your Windows Explorer if you're in Windows. So if I navigate to this folder, it was NYC no context, and tell it, hey, there's where that simulation is, then it finds the rest of them in that folder. Okay, that's this first assignment. It's intended to be quick, down and dirty. I'm hoping to do most of it in class with you. If you are in a different class and you were assigned this and there's any confusion, I'm happy to help you with it. fsnell@nyit.edu. Send me an email and we'll talk about it, or send me a screenshot, send me your model, I'll help you. All right, talk to you soon.